Good morning to everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about the double sideband communication. Double sideband DSB-SC we'll call it as, and it is nothing but a double sideband suppressed carrier is an amplitude modulated wave transmission scheme in which only sidebands are transmitted and the carrier is not transmitted as it gets suppressed. The carrier does not contain any information and its transmission results in loss of power. Thus, only sidebands are transmitted that contains information. This results in saving of power used in the transmission. Then the generation of a double sideband suppressed carrier signal. Here we are using a product modulator. Here in this product modulator, the signal is obtained by the multiplication of the input signal which we are giving and a carrier signal by the frequency shifting property of the Fourier transform, where we have seen this equation already in the amplitude modulation wave. So by comparing with that, we'll get a two sidebands that are placed in that is plus omega c and the minus omega c. Then the mathematical expression of this double sideband suppressed carrier wave is the baseband signal is nothing but x of t ax cos 2 pi fxt, and the carrier signal is c of t ac cos 2 pi fct, where this ax and ac is nothing but a modulating signal and the carrier signal. The mathematical representation of the signal at the output of the product modulator is given as the multiplication of these baseband or modulating signal or the carrier signal. Further, we'll get s of t which is equal to ax. If we multiply the above both equations, we'll get the final result. Where in that signal will be first one is a modulating signal, the second one is a carrier signal, and the third one is second one is a amplitude modulated signal along with the carrier wave. And the third one is the suppressed carrier wave. The maximum bandwidth, that is bandwidth is nothing but the maximum frequency is fc plus fx, and the minimum frequency is fc minus fx. As we know, the bandwidth is given as maximum minus minimum. Will if we difference these two maximum and the minimum frequency, we'll get the bandwidth of double sideband suppressed carrier as 2fx, where the frequency is twice the frequency of the baseband signal. That is, the signal which contains the frequency is is twice the frequency of the baseband signal. The following are the two modulators which generates the double sideband suppressed carrier wave. First one is the balanced modulator, and the next one is a ring modulator. In balanced modulator, we'll be using two modulators which are arranged in the balanced configuration. So, in order to suppress the carrier signal, the modulators are arranged in a balanced mode. So, we call it as a balanced modulator. The carrier without any information content is suppressed by the balanced modulator. Its principle of operation is such that when two signals of the different frequency are passed through a non-linear resistance, then an amplitude modulated signal with the suppressed carrier is achieved as the output. This is the diagrammatic representation of the balanced modulator. Then the next one is a ring modulator. Here we'll be using four diodes which are connected in the form of ring. Hence this modulator is called as a ring modulator. Here we'll be using two center tapped uh, here we are using two center tapped transformers in order to apply the input signal to the transformer. Then we'll be seeing the operation of this ring modulator, uh, where by combining all this, where these four diodes are controlled by the carrier signal. So this double sideband suppressed carrier modulators are also called as a product modulators, as they produce the output which is the product of the two input signals. Then double sideband suppressed carrier demodulator. The process of extracting an original message signal from the double sideband suppressed carrier wave is known as a detection or demodulation of the double sideband suppressed carrier. Hmm. And it is of two types, that is coherent detector and the Costas loop. In coherent detector, we'll be having a product modulator and a filter. In this process, the message signal can be extracted from the wave by multiplying it with the carrier having the same frequency and the phase of the carrier, which is used in the demodulation. The remodulated signal amplitude will be zero when pi is equal to plus or minus 90 degree. This effect is called as a quadrature null effect. The next one is a Costas loop. It consists of a two product modulators with the common input, and the other input for both the product modulators are the voltage controlled oscillator. And finally we'll be having the assessment part where what is mean by the product modulator, and define the quadrature null effect, and mention the uses of voltage controlled oscillator. Thank you.